All right, Janet, feel free to go ahead.
Great. Well, welcome everyone. Happy GIS Day. I'm Janet Reyes from UC Riverside Library, and welcome to this session on GIS Grab Bag. We have three awesome presentations today for you in this session. And first up, we have Claire and Wayne from UC Santa Barbara. And so when you both are ready, feel free to take it away.
Okay, let me get this queued up right here. Mm,
And I will say, we welcome your questions, but please put them in the chat as the presentations are going. We will then answer all the questions when the last presenter has finished.
All right, let me know if this all looks right.
It
There's,
does, yes.
okay, great. Hi, welcome to GIS Grab Bag. We're the first of the grab bag, and we'll be talking about our project identifying suitable burrowing owl habitat at Jack and Laura Dangermond Preserve, and the Esri field maps and ArcGIS Pro applications in conservation ecology for this cute little grumpy owl right here. So my name's Claire Wilhelm Safian. And my co-presenter will be Wayne Chapman, kind of our burrowing owl guru. We work at the Cheadle Center at UCSB. We do lots of habitat restoration and conservation of rare and endangered species. So I'm going to hand it over to Wayne to give kind of a life history of the Western burrowing owl.
Okay, sure. So this is the Western burrowing owl. It's a different subspecies from the Florida burrowing owl, and there's one on our campus at one of our constructed artificial burrow entrances. They are, I suppose you could forward the slide, Claire, if you like. So yeah, severe decline. Most of the population maps are outdated, but the earliest records from our county and the general region was common, abundant, year-round breeding. And today they're completely extirpated as breeders in our county and in most of Southern California's coastal habitat, except for a little bit in Orange and San Diego counties. And we just have very low numbers as winter visitors coming from places like Western Oregon and Washington, or Eastern Oregon and Washington. So lots of threats. Urbanization has taken up all the flat places. Lots of introduced trees are terrible for these birds. They favor great horned owls and red-tailed hawks. And ubiquitous spreading of weeds, mustard, and grasses that cover burrows, and then persecution of ground squirrels has all kind of led to a perfect storm for this species. So next slide.
Yeah, so this is our study area. We were working at Jack and Laura Dangermond Preserve. It's managed by the Nature Conservancy. It's over 24,000 acres. That was in the past few hundred years a privately owned ranch around Point Conception. This was purchased in 2017 with a $165 million donation from actually the Esri co-founders, Jack and Laura Dangermond. So it's kind of an interesting full circle that we get to use their products to manage land that they helped acquire for the TNC. So in our area here, we're actually going to be looking mostly at this section here, which we call the Coho Terrace. It's around Point Conception, so you can see there is in California's coastline a section that is largely runs north-south, and then at Point Conception and in Santa Barbara County, it starts running east-west. So this is kind of a natural stopping point or overwintering site for lots of migratory birds, including burrowing owls. And the sheer size of our project here means we have quite a bit of ground to cover. So this section of the preserve is 1,045 acres total, largely grassland, coastal sage scrub, and dunes. So how are we actually going to manage to cover all of this in a few months with only a handful of visits? So what I did is I used the Clearing Grids toolset in ArcGIS Pro to create a 10-meter resolution grid that's aligned with the MGRS, the Military Grid Reference System, just so it is uh, aligned with something that we are all kind of familiar with and can map onto other maps. Um, and each one of these grids is just given a sequential ID number so that we can reference it in the field. And within this study area, we are just going to be going through, walking in a relatively standardized way so that we're covering as much ground as possible. And within each 10 by 10 meters, if we see a burrow, we're going to stop and give it a little rating. So we set up this field map survey. Basically, in the field, you'll have your giant grid, and you can just tap on whatever cell you're in, and it will pop up with a bunch of questions. The date and time on which you are recording your observation, burrow, just a simple yes or no, and then the burrow suitability. So for that, we have kind of a ordinal classification system. Um, it's basically a priority index for the best habitat to the least good habitat as it currently is. Um, One is a good burrow with evidence of owl usage, so there's poop and or pellets right outside of it. Two is looks like it would be suitable, but for some reason the owl isn't using it. We see no evidence of them using it. Three is a substandard burrow. It is obscured by non-native invasive plants. And four is a substandard burrow obscured by native plants. So what did this actually look like in the field? Wayne, if you want to talk about the actual conditions of um, data collection.
Sure. So I should also point out that there were hundreds and hundreds of,
Yeah.
almost all of these were made by badgers. So very few ground squirrels on the preserve for some reason, probably due to historic persecution over the ranching era, since ranchers don't like ground squirrels. And we saw hundreds and hundreds of burrows we did not even record because they were too shallow. So these were essentially ones that we could determine were at least 24 to 30 or so inches in depth so that they could get away from a raptor. Um, so you typically, if a coyote comes along, they'll fly, and they go into these burrows when northern harrier, great horned owl, red-tailed hawk, which is common, comes around. So this was a good burrow. You can see the poop kind of on the left there. So if we either saw an owl or if we had evidence of them using them pellets or poop, that was the best type of burrow. And I guess next slide.
Mm-hmm.
And so here's a large section of the preserve, tabletop flat, great habitat, except it's infested with Ehrharta calycina, which is a veld grass, introduced plant from Africa. And it is not only a non-native species, but it is extremely thick and dense. And so this grass density is really prohibitive to burrowing owls, even though from a bird's eye view, it looks like a grassland. It's really too thick for them to hunt in and find burrows in. So next slide. So here's a good one with poop or pellets. You can see the one on the left has lots of poop, even though it's slightly obscured, they were using it. And the one on the right had some pellets that we collected. We're also doing a study right now of those pellets, dissecting them, trying to determine what their diet was. Next slide. So here's a nice burrow that appeared deep enough, but no evidence that it was being used. Next.
Yeah, here I'll hop in to say how we actually tracked our progress throughout it. So you may have heard of Field Maps Track Viewer, um, which is just a way to see where users have gone throughout the day. Because we not not the best practice is we kind of share an account, us at the Cheeto Center. So it wasn't necessarily an option for us because we might have multiple users using the same account at the same time. So it wouldn't be feasible to be able to track our steps through that feature. So instead, I just did my own ad hoc version of this. Surveyors had a line layer that they would just click start or stop streaming whenever they were on the move. And that way we could get a good idea of all of the ground that we covered over the course of a few, I don't know, it was probably over the course of about a month and a half, various visits. So, yeah.
Yeah, and not every person was tracking. So there might have been one person tracking and three people walking. And if somebody saw something, they would call the data recorder over. So there's actually more walking than is represented there.
True.
Yeah.
And this is what we ended up with. We have our best active burrows in green, and then potential burrows in yellow that we had no evidence of owl presence in. So we had a total of 43 active burrows, 18 owl sightings, and 172 potential burrows without evidence of owl presence. This here is a layer that represents raptor perches. So predators such as great horned owls and red-tailed hawks might be using these telephone poles and trees, crossing lights, anything over 3 feet is a decent enough raptor perch to give them a wide view of the landscape, of this wide open landscape, and be able to pick off burrowing owls, these ground nesters. So from previous studies, we know that about 140 or 150 yard buffer is going to be this like area of avoidance that burrowing owls will not want to be anywhere near these structures. So, of course, we have one running directly through the center of our wide open area here. These are telephone poles. We have a few windrows. This one is Monterey cypress, and these green ones are eucalyptus trees. Blue gum eucalyptus is extremely tall and a great way to advantage those predators. Um, yeah, of course. So we have wide open landscape, but then those perches are kind of precluding that habitat from being used by burrowing owls. Here we have an example of a raptor using a telephone pole. So if we overlay that, we end up seeing kind of gaps where there are suitable burrows near these. A lot of yellows all along those windrows, but not so many active burrows. So we were kind of we started with this hypothesis that we wouldn't see that many, and that ended up being true. So how do I actually did that in ArcGIS Pro? Is I started with that question, is how close are the active burrows to the predator perches? And I generated a near table, first of all, and then with those near points, used XY to line to find the distance between perches and the nearest active burrow. And then I created also a 150-yard avoidance buffer around it. That's what this like transparent orange is. And indeed, we see that there are only 3 active burrows within that avoidance buffer, and they're actually close to telephone poles rather than any of the trees. So there's this one right here, and then there's actually two owl sightings within the buffer, but these are all telephone poles. So because there's not a whole bunch of foliage and branches, they aren't the burrowing owls can spot predators a little bit easier. I also did a kind of cursory supervised classification using NAIP imagery to get an idea of tree cover, and we came up with this figure of it's about 11.3 acres. Only 1% of the study area is tree cover. And yet, if we factor in the actual avoidance buffer, it precludes 315 acres of habitat. That's 30% of the study area. So trees have this outsized impact on burrowing owl habitats. Just a cleaned up map version of that. And we're running a little low on time, so we'll kind of rush through some recommendations here. With the shifting sandy soils in this area, the specific burrows that we mapped are likely impermanent. They can collapse, cave in. We'll have new ones next season with new badgers, new ground squirrel holes. So they're not as important as the overall pattern that we observed, the distance from the raptor perches, correlation with native and invasive species cover, etc. So some things that we recommended to TNC following the study is construction of artificial burrows that are less prone to cave-ins and centering them in those good habitat areas away from telephone poles, etc., etc. Also, invasive species management in that core habitat, especially perennial grass, since that's so tall and can really push burrowing owls out. And then finally, removing some of those tree windrows and undergrounding power lines. That is pretty close to a Coast Guard station, so DOT could potentially be on the hook for that, but yeah, or rather DOD, not DOT. Yeah. So, Wayne, I don't know if you want to add anything there about recommendations, or we're running a little bit over time.
Yeah, you about covered it. Basically, trying to encourage the Nature Conservancy to prioritize these critically endangered birds. They're not listed as endangered yet in California, but they're literally critically endangered. And so break some eggs to make an omelet and cut those trees down.
Yeah. If you're interested in reading the full report of this, there's a QR code right there. And then are we taking questions now or at the very end?
We will take them at the end,
Sounds good. Yeah.
but people are
Close the
free
chat.
to put them in the chat at any time. So
Alrighty. Let me stop screen sharing here. And I'll hand it over to the next one.
okay, well, we want to thank you, Wayne and Claire, for that really interesting presentation. So as I just mentioned too, if you do have a question, please feel free to put it in the chat, but we won't actually ask the questions of our presenters until the very end of the last presentation. And so next up, we have Natasha from ECSF, and happy to have you here. And please start when you're ready.
Thank you. And I will try to stay within time here. But thank you, everyone, for having me. My name is Natasha Ludwig Barron, and I'm an epidemiologist and assistant professor at UC San Francisco. And this is my second UC GIS week. So I'm really happy to be here, first time presenting. But I love the virtual nature of the conference, but I do sort of miss the interaction of being around geospatially minded people. So if you don't mind and you're able, if you can drop your name and either the location you're coming from or the organization that you're with in the chat, that would be super helpful. We are the Grab Bag group, so you'll see a lot of diversity in topics, and but I'm already seeing parallels in some of the analyses that we do. Let me see if I can progress. Okay. So just a few opening remarks in my positionality. I'll start with a land acknowledgement, noting that the land we're on today was unjustly colonized from Native communities, and we at UC San Francisco and other UCs are here benefiting from that colonization. And yes, I'm a Chicana from an underrepresented group in the sciences, but this is always a reminder for me and other scientists that we should push to be better than the colonizers who came before us. And from a healthcare perspective, we should strive to conduct ethical research and provide the best quality care that is culturally and linguistically appropriate, regardless of someone's immigration status. Second, I have no conflicts of interest to report, but I do have a few disclosures to make. And the first is the findings that I present today do not necessarily represent the views of the National Institutes of Health. In the presentation, you might see that shorthand PWID that refers to people who inject drugs. And third, because of the nature of where I work, who I work with, and what I study, it's almost impossible to make this a bipartisan talk, meaning that I work within a harm reduction framework, which has been removed from SAMHSA's and other federal websites across the board. And lastly, for those on the call today battling addiction, parts of my presentation may serve as a potential trigger. And if you choose to continue with us, I ask you please be ready to contact your sponsors and other support mechanisms. So first and foremost, I have to acknowledge all of the people who contributed to the research, including our partners at Programa Compañeros, who are the sole harm reduction organization in Ciudad Juárez, Mexico, and who are really the champions of this study. El Paso Community Foundation is up there as well, and colleagues and mentors from UCSF, and of course the funders from NIMH and NIDA. So I know that not everyone is in the HIV area. We have so many topics being presented today, so I thought I'd just orient us a little bit about the HIV epidemic that's happening. And these are numbers from 2022, and so we know that these might be off, and we predict that they have actually gone up in the last year. So in 2022, there were 39 million people living with HIV, 1.3 million people received a new diagnosis. And globally, the mortality is over half a million people. And within the HIV space, we refer to key populations as people who are disproportionately affected by HIV. Those would be men who have sex with men, sex workers, trans and gender diverse persons, prison populations, and people who inject drugs, who are the sole focus of the talk today. So let me bring everyone to the group that I've worked with for over 20 years now, which is people who inject drugs or communities who inject drugs. And when we think about HIV prevention, we really have to think about two modes of transmission, which is injection practices and sexual behaviors. And I also have to mention that, people who inject drugs, they have multiple identities. So before I told you about our key populations, well, people who inject drugs can also be sex workers. They can also be men who have sex with men, gender diverse populations. So we're working with multiple identities when we talk about communities who inject. And although the topic that I'll be presenting on today is on HIV prevention for people who inject drugs, I do study a lot of the comorbidities, including overdose, hepatitis, and tuberculosis. I sort of glossed over this, but again, just to bring us at the same level and the same playing field, I typically work with harm reduction organizations in all the research that I do. And they have this philosophy of meeting people where they are in their addiction, no matter how they come to them. A lot of their outreach services are at a grassroots level. So within communities, they have to leave facilities, they have to leave your traditional clinic settings to go out to communities to meet people with services. And in my experience, there are no two harm reduction centers that are the same. They're typically known for their needle exchange programs. That was based in a lot of the work done in the early 80s when the HIV epidemic started. But they've grown to so much more. They are really this segue into getting into treatment, to getting into care, to getting people housing and social services. And so you'll see that a lot of them offer multiple services. And for everything that we do in health research, we have to work with harm reduction organizations. I mean, they're so trusted in the community. They've built and established that trust over so many years. And so anything that I do is typically through a harm reduction organization. And I'm lucky to and very fortunate to be working with Programa Compañeros, who is in Ciudad Juárez. So let me orient you and let me take you to where I work, which is Ciudad Juárez, Mexico. And so if you look at the photo at the top right, you will see the vast environmental differences, right? So on the top half of that photo, you see Ciudad Juárez, it's dense. You see a line that sort of transverses in the middle, and then south of that is El Paso, Texas. And they sit on this corridor between El Paso, Texas, New Mexico, and the Mexico border. And so it's a sprawling region with over 2.7 million residents. It's very transient with more than 35,000 daily border crossings. And politically, it's been known as being a major drug trafficking route. In the last couple of years, there's been over 6,000 asylum seekers come through the region, and really, the social services, the social service programs in the region have really taken a hit. And then I'd be remiss if I didn't mention the area is no stranger to violence and trauma. From a substance use perspective, it's been a longstanding issue. There's more than 10,000 people who inject drugs. Most of them are injecting opioids. About 1 in 4 are women, and 11% or a little over upwards of 10% are living with HIV. At at the time when I was working with compañeros during my postdoc, they didn't know how many people were actually sharing injection equipment. They knew that it was common, and even though they hand out syringes, they knew that there was a higher demand in the community than what they were giving out. And that is, again, sort of politically enforced because of there's not a lot of options, and they knew that they weren't receiving enough needles to distribute in the community from the federal government. And so our harm reduction organization, Programa Compañeros, is really enthusiastic about doing research, and sort of our relationship has evolved. And where my mind has now gone is how do we really move our science and our advanced data analysis into community spaces? And GIS is one of those tools where everyone can identify with a map. And so I received training during my doctoral phase in geospatial analysis. And so I thought after meeting with them, some of their questions sort of lended themselves to a geospatial analysis. So their research questions were very pragmatic in nature. How many people are using injection equipment? Where are the high density or hot spots for sharing injection equipment in Juarez? And where are 3 outreach locations where they could maximize their reach to deliver HIV prevention services? On the right, you see what it actually looks like in the field to deliver services out to communities. Most of our outreach workers are in recovery, and so have been part of the community themselves. Like I mentioned, this was through a pilot grant during my postdoctoral phase and is now grown, but the original study started back in 2023 from June to September. And it was a cross-sectional study design where we recruited people who injected drugs in the previous month, 18 years or older, living in Ciudad Juárez, Spanish-speaking or English-speaking, willing to complete an HIV environmental survey and provide coordinates of where they shared injection equipment. This is an example of the survey questions that I had in our survey. So have you had to share injection equipment in the last year? And can you recall the locations where you shared injection equipment on the map? And we had an iPad with a Google Map Street View, and so they could actually pin. Those pins were then imported into RedCap, and then you'll see the analysis was in ArcGIS Pro. And so the analysis yielded our heat maps, which indicated sharing density. And then I conducted a location allocation analysis, which it has many labels. It was developed in really the business world to really maximize reach and how do you reach the public for a service or for a product. And when talking with Programa Compañeros, they were interested in going to 3 different locations per week. So I had a conversation about how to calibrate for them. They said, their travel radius for folks is about a 30 to 40-minute walk, which ended up being 2.5 kilometers. And so the results you'll see here, just a snapshot of our participants. So we had 149 participants enroll, 70% reported sharing injection equipment, and 99% provided coordinates. And that was all thanks to working with a harm reduction organization. I couldn't have asked people sitting at a university or a clinic to provide me with these coordinates. It has to be done through a trusted entity. And of the 103 people that came in, they provided 142 coordinates for us. And I think that's also really telling that people were comfortable giving more than one coordinate. Generally speaking, the majority of the population was male. That wasn't surprising. I have the substance use breakdown of what they were using. Everyone was using heroin, then that was followed by sedatives, marijuana, crack cocaine, opioid pills, and then meth at the end. 84% have less than a high school education, and 15% experienced time in jail or prison in the last year. And then 82% were Hep C antibody positive. And so this first figure is plotting those coordinates and doing that heat map for them. And so I'll orient you to the map first. So at the top, you see here the U.S.-Mexico border. The north side is El Paso, and the south side here is Juárez. And this hotspot region where you see a lot of activity, that is actually the metro downtown area for Ciudad Juárez. And having conversations with our organization, our community partners, they were somewhat surprised to see some of these hotspots popping up to the west and then also to the south down here. The south is mostly industrial. Where the Legend currently sits, that's like a mountain range. So there's very little habitation over there, but this whole area to the west is majority of it is residents and close living quarters, densely packed living quarters. Down here to the south is a little bit more industrial, and you'll see a little bit more zoomed in. And so from here, we did our location allocation analysis. Again, the parameters were 2.5 kilometers and 3 sites. And it yielded 2 of the sites being in central Ciudad Juárez and 1 out to the west. So you can see superimposed on our heat map, our nodes, and then you can see where the suggested sites, outreach sites were for the metro area, which actually fell really close to where Programa Compañeros has an office, and then also to the west. And then again, somewhat of a surprise, it sparked up a lot of conversation, was the site that we found to the south. You can see here at the very bottom, that's the airport. And then to the left corner here, the bottom left corner, that's a little bit more where the mountain range starts. But you can see at the foothills, that's where our analysis said that we should place an outreach worker. So in conclusion, participants were willing and able to provide us with coordinates. Again, that was only made possible by working with a harm reduction organization. Most hotspots were in the Metro Ciudad Juárez area, but there were a few unknown hotspots west and south of the city. And the location allocation analysis was useful in suggesting 3 outreach locations with the greatest need to maximize HIV prevention services. And previously, South Juárez had not been receiving consistent services, but this analysis definitely showcased why we do need to go there more often. So for the next steps, I love this picture because this was actually a conversation that we were having, and when I was showcasing all the maps and what we had found and all the data that we found in our survey. And so this led to actually our next steps in doing a participatory GIS project, which I've never done before. We are learning as we go. But our next question is just to understand where resources are for this community for people who inject drugs. There is a lot of stigma that is out there. And so there are different services that might not be suitable for people who inject. And so we are doing a two-step process, the first being canvassing using a Google Street View of places that you would think of for resources. So like clinical resources, treatment resources, housing resources, pharmacies. But we're also thinking about non-traditional resources like cultural and religious resources that might be available to folks, mutual health groups. And we're using a community advisory board to then go back and look over and evaluate our Google Street Map because we know that some of those images are older, they're pre-COVID in some areas. And so we are using our community advisory board to see which resources are actually still there in the city, and then also which resources they would recommend adding. So stay tuned for that one. And I just want to thank everyone for their time today. I do welcome feedback, and I love to hear where other people have published, any recommendations, any analyses that they've done. And so I welcome the conversation, and you can reach me at the URL code below. Thank you.
Thank you, Natasha. That was so interesting. Yeah, great research and a great presentation. So thank you. Next up, we have two folks from UC San Diego, I believe. Jipeng Chen and Michael. If you are ready to present, we can turn the floor over to you.
Can you hear me?
Yes.
Thank you very much. Hi, everyone. My name is Zhipeng Chen, and I'm a research data analyst at the Power Transformation Lab at UC San Diego. I'm very excited to be here today with Michael to share our work on the Geodata package and how it supports energy and climate research workflows. Michael, I'll pass to you now.
Hey guys, I'm Michael. I'm an undergrad at UCSD and I'm working with the Power Transformation Lab on Geodata with Bill. So basically, Geodata is an open source toolkit designed to streamline the process of downloading, processing, and integrating Earth system and geospatial datasets. So it's a really nice library, and it's particularly useful for renewable energy research and climate analysis, since it gives really easy access to a wide range of relevant datasets. So first, I just want to introduce the Geodata team, which includes Professor Michael Davidson and several other talented researchers and developers from the Power Transformation Lab at UCSD. You can see their names down below. So basically the point of Geodata is to simplify the often complex task of accessing and manipulating geospatial data and allowing researchers to basically focus on their analysis and insights instead of the whole process of getting that data there in the first place. So the challenges that we're looking to pretty much solve are the data accessibility barriers. So high resolution Earth system models often offer really good historical records and very detailed spatial coverage, but they have really massive file sizes for downloads, and that creates a really big computational barrier to researchers. So basically, we then find the critical datasets for renewable energy siting, land use analysis, and socioeconomic evaluation. And those tend to also have inconsistent formats and resolutions and coordinate systems. So this really makes the workflow difficult. And researchers end up wasting a lot of valuable time trying to navigate all these different APIs, convert file formats, and trying to harmonize grid structures rather than actually just focusing on their scientific analysis and insight generation. So basically what Geodata does is we have these simple one command downloads of Earth system data, and you can specify the region, your time period, and your specific variables of interest. And those are all specified in configurations. And this basically seamlessly integrates your NetCDF climate data with your GIS layers for spatial analysis. And the end product is these nice analysis-ready data sets that have consistent formatting and metadata that your researchers can all use interchangeably. And then kind of the best part about this that saves a lot of time is that all of the workflows for this are reproducible. So your research can be very collaborative. So just again, it's important because it eliminates these massive download barriers that are scattered across hundreds of different locations with disunified data sources and inconsistent APIs with different coordinate grids and units. And this ends up dramatically reducing the time from data acquisition to analysis. And again, it ensures the reproducibility since you have standardized workflows across your lab. So Geodata is basically built up from 4 core modules. So you have the dataset module, the cutout module, the modeling module, and a masking module. So the dataset module basically has unified API calls, and these calls are to major climate data repositories like MERA2 and ERA5 reanalyses. And then you have automatic credential management within the package itself, and you can parallelize downloads, which like speeds up the process just a ton. The cutout module lets you extract and transform data into your analysis-ready output variables, and you can even add in spatial and temporal subsetting into it, which is really nice. And then the modeling module lets you generate weather-dependent renewable energy profiles, and you cross-validate these with wind, turbine, and solar panel models from the AtLight library. And this is all built into the package itself. So this is all like something that you can do straight from Geodata. And then finally, the masking module lets you kind of merge geospatial layers in and apply different suitability criterion and environmental constraints to feed your resource assessments. So let's say you want to do wind resource assessment for offshore regions, Geodata has you for that. If you want to do solar photovoltaic analyses, then Geodata can do that as well. Yeah. So the first module, again, the dataset module. The netCDF files can be big, so the dataset module helps shrink these initially. Each data source can be organized differently, and our approach is just to have single line download commands that have locally stored API credentials, and we leverage Xarray and Dask for parallelization. The system automatically ends up trimming your data sets to the essential variables and standardizes metadata formatting across, say, MERA2 or ERA5. And so currently, the dataset module supports MERA2, ERA5 reanalyses, and it also has support for TIFF and SHP geospatial formats.
Thank you. Oh, keep going. There's one more slide.
And then within the dataset module API, you can kind of see some example usages for API calls for MERA2 and ERA5. It's very, very simple. So like even if you are someone that isn't very proficient with programming, you can just look at these workflows and be able to pretty much get going from there. And so again, the key features basically consist of these single call downloads, automatic trimming within the package, and you have all of this just driven by like 1 or 2 configs within the library. And again, you have wind support, so you can have wind like renewable energy resource evaluation, and then you have solar photovoltaic support. And that's all just built into the package.
Okay, thank you, Michael. The cutout module is a very powerful tool that allows researchers to extract specific data from large global data sets to meet their analysis need. So you can extract desired data set and variables within specific geographic bounds and time periods, converting raw data to energy relevant output like wind and solar generation profiles, which makes it easy to export the data to CSV or binary format for your analysis. The module also supports a range of conversion, including wind power density, solar PV factors and temperature and PM concentrations. The tables on the right shows an example of data transformation pipeline the modules enables. So from raw inputs to desired analysis-ready output. Here's a comprehensive case study of the Qatar module to analyze the PM 2.5 air quality in the Beijing region using the MERO2 dataset. So first, we will create a dataset object from the MERO2 weather data. Next, we will define the geographic cutout to specify the region of interest and the time period of 2020. And finally, we extract the PM 2.5 profiles by applying the conversion function to generate the hourly PM concentration time series for the study region. Now we have the PM 2.5 data array output, and now we can perform the advanced analysis and create the data visualization to uncover the spatial and temporal patterns of the output data. So this two time series line plot compares how PM 2.5 changes over time in Beijing in year 2019 and 2020. You can also build an animated data visualization from the output data. So this visualization provides an interactive look at the PM 2.5 air pollution dynamic across northern China throughout 2020, which reveals like interesting temporal patterns and trend in air quality over the course of the year. This help us identify like pollution hotspot and understand seasonal variation and track the impact of policy change or other interventions. The mask module provides a powerful geospatial integration solution to address like common challenges in working with diverse GIS data format, spatial resolution, and suitability criteria. So it leverages like robust open source libraries to enable flexible layer management and intuitive plotting functions. This module like simplifies the integration of spatial constraints with temporal resource data and enable more comprehensive analysis and decision making. This module has like three powerful technical features for working with spatial data and generating energy values. So the first one, layer management, allows you to create, add, and manipulate like shapefiles and raster layers. And the second, spatial operations, allows you to merge multiple layers, flatten composite masks, and extract specific geographic shapes from complex constrained datasets. Lastly, the cutout integration feature allows you to combine mask values with temporal resource data to generate area-weighted or mask-weighted energy values. Now we have introduced all the modules. I will demonstrate a step-by-step workflow of a typical geospatial geodata project. So this example shown is a solar resource assessment in China. So first we will load the dataset, ERA wind and solar dataset for the study region covering 2015. And next we will configure the solar panel model and the solar model parameters to represent the technology we want to use. And after that, we can generate the hourly solar PV capacity factor profile using the weather and solar radiation data. Next, to account for spatial constraint, we'll load land use and protected region data to create a comprehensive sighting mask. And finally, we can combine the PV generation profiles with the spatial mask to calculate area-weighted and mask-weighted hourly generation values. And next, we'll show you 3 research projects that were conducted using geodata. So the first one shown is a research project that aimed to analyze the supply curve for solar development in China, which reveals the cost resource trade-off. We found that China has abundant developable land across multiple climate zones, but the most optimal resources are located in certain areas. So this supply curve analysis help us inform decision around where to prioritize solar infrastructure investment to maximize the output at the lowest cost. The second research explores how renewable energy development can be strategically directed to support a just transition for coal industry workers in India. So the methodology involved integrating district-level co-employment data with the assessment of renewable energy resource quality to identify overlap between high coal industry areas and good renewable potential. So the key discovery here is that district with substantial coal industry presence often poses the strong renewable energy resource. So which indicates that significant opportunity to target clean energy investment towards the community most affected by the energy transition. And the third research project here focuses on assessing the renewable energy resource in the Western United States. The project demonstrates Geodata's capability of integrating environmental constraint dataset with climate data for renewable energy planning. So the two images on the right provide a visual example of the data and analysis used in this project. Lastly, I want to conclude that Geodata is a very useful and important tool for renewable energy research and development. We are actively working on the model validation and improving the performance of our dataset and analysis modules. And the Geodata project welcomes contribution from the research community. You can find us on GitHub and reach out to me directly with any feature requests, bug reports, or code contribution. And I'm very happy to discuss the project and how you can get involved. Yeah, thank you everyone for your time.
Thank you both. Again, amazing work.
Thank you.
I'm just processing what all that means for researchers. And this is a time that we have for folks to ask questions of any of our presenters. And I haven't seen any questions come through the chat, but if you have thought of something that you would like to ask, you could raise your hand right now or unmute. And I have some questions bubbling, but I just want to make sure everybody else has a chance to ask anything that they would like. Okay. Well, I'll start with a question for our first presenters. I was noticing at the end there was talk about one thing to help the burrowing owls along was to remove trees. And I'm imagining that there's kind of a conflict perhaps with that idea as how that tree removal might impact other species, or there might be some resistance to that kind of management practice. So
Yeah.
I know it's up to the decision makers ultimately, but I just didn't know if you had any commentary on that.
Yeah, I think politically there is some pushback. I think in lots of environmental minds, trees equals good. I think it is context specific. In Santa Barbara County, we don't have native trees that are nearly as big as the trees that were introduced. Blue gum especially is huge compared to our coast live oaks. So if we're thinking in a restoration mindset, this probably is a huge factor influencing burrowing owls is that we've skewed the landscape to favor their predators in the last 200, 300 years. There, I know Wayne is probably chomping a bit here to talk about that, but yeah, I don't know. Do you have anything else to add, Wayne?
Yeah, I would just say excepting California condors, these are easily the rarest raptor in California. And another one that's a major burrowing owl predator is northern harriers out there, but they really like grasslands. They actually do nest on the ground, and they would probably benefit from less great horned owls and red-tailed hawks. But if you think about great horned owls and red-tailed hawks, they basically occur from the West Coast all the way to New York and literally everywhere in between in every biome. So um, there's just so few wide open flat places on the coast of California that remain that this should be and again, 1% of the cover removes 30% of the effective habitat for burrowing owls. So yeah, they really need to be viewed objectively, not if you leave it to people, they'll leave trees because people like trees. But unfortunately, yeah.
Good deal. Well, thank you for that answer. Appreciate that. Moving on to Natasha, I don't know if it's really a question, but I was just blown away by the high level of participation of people willing to share coordinates on a map. I imagine they might have some suspicion or some risk involved in disclosing some of those locations. So I don't really have a question. It's just that was just so surprising for me.
Yeah, no, for me as well. I think we asked about syringe sharing, sex work coordinates, and where people are injecting drugs in general. Again, wouldn't have been possible if I didn't work with a harm reduction organization.
And I think it's really smart to kind of do a check, looking at Google Street View, but then also checking to make sure those locations are still what they were the last time the Street View was uploaded, because I know that happens. There can be dramatic changes in 5 years or whatever. So yeah, that's a smart move there. Thank you.
Thanks for having me.
Yeah. And then Bill and Michael, that product looks amazing. And the first thing a couple of things I'm thinking about is, do you have a sense of how much time was reduced in the span of somebody's research project because they could use your tool? Like what it would have taken them, the length of time it would have taken them if your tool was not available versus having this tool available. Do you have a sense of how much time was reduced by that?
Yeah, definitely a lot of time will be reduced. First, for researcher, important things that they want to consider is to find the right data set. Instead of like Googling and asking people where they get the data set, we have the right data set, and each data set is configured and in detail what variable they have. And some of the data set are huge, and they have like hourly data, which is crucial for researchers if they want to do like energy and climate research. Also, after they got the data set and they got the variables they want, they might also want to apply some layers or mask to see what's really important. And our package like have that module integrated, so they can instead of like writing multiple lines of code, one command can do that. So definitely a lot. Also for the plotting, they want to have a cool data visualization that's also integrating into our package, which it is very convenient for researchers to have the result they want.
Right. Amazing. And just real quick, I imagine that there are other types of research that use raster data, global time series, that maybe your approach could be applied to those types of data sets as well.
Yeah, absolutely. So for our dataset module, we currently only focus on weather data from the two sources. So one is MER2 and one is ERA5. But we definitely are looking to expand our data set in the future.
Awesome work. Well, thanks again one last time to all our presenters, and thank you for your amazing work.